Alright guys, this lesson is a little review of some Algebra 1 skills. We're going to focus on simplifying radicals as well as some radical operations. So I'm going to teach you guys two different strategies for simplifying radicals, and you can choose which strategy you like better. You might see that in some examples, strategy 1 will be easier, and some examples, strategy 2 will be easier. So here's strategy 1. Giving you guys a pretty easy square root. You guys already know the answer to that is going to be 6, but I'm going to show you guys the strategy using this pretty easy square root. All right. The first step, if you're using this strategy, is to expand this radical into as many factors as possible. You can use a factor tree. So, for instance, if I wanted to do a factor tree of 36, I can think of any two numbers that multiply to 36. I could do 6 and 6, and I can break down 6 to 3 times 2. 3 times 2. And then you just want to focus in on the ends of those branches. And you're going to write them in under your radical sign, which you guys can see here. So, or within your radicand. Okay, 3 times 3 times 2 times 2. Next step will be to circle anything that's 2 of a kind. Okay, because we're dealing with a square root, not a cubed root, not a fourth root or a fifth root. We're finding 2 of a kind because it's a square root. So I have 2 of a kind there, my 3's, 2 of a kind there with my 2's. And then my next step is to pull out the numbers and place one of each to the left. So if you guys look at what I had here, I cross out the pair, I write one to the left, cross out the pair, write another one to the left, and then 3 times 2 gives me 6. All right. So you guys can pause the video, use that strategy to simplify the square root of 160, and then we'll go over it. All right, here's your answer for strategy 1, example 2. Realize, guys, that your factor tree could look different. So, for instance, if you broke down like 16, first is 4 and 4, you'd eventually get to the same prime factors. So it doesn't have to look exactly the same, but you should have under your radical sign right here, 5 2's and 1 5. When you find your pairs, you cross one out, write one to this side, you cross another one out, write one to this side, and then you're left with 2 and 5 inside your radical. And then just to simplify that, multiply together what's in outside your radical and what's inside. All right, so 4 red 10 is your answer. All right, let me show you guys the second strategy. So with this strategy, if I'm applying that to the square root of 36, you want to ask yourself, what's the largest perfect square that divides evenly into the number inside the radical, and then put, they say him, but put it under the first radical sign. Right? So say it didn't occur to me for 36 that 36 itself is a perfect square. I could break that down to the square root of 9 times 4, right? So because the square 9's relatively big perfect square. That goes into 36. From there, I could then take the square root of 9. I know that's 3. And then I will realize square root of 4 is 2. 3 times 2 gives me 6 there. Right? So for example 2, strategy 2, you already know what the answer is, but think about approaching it by asking yourself, what is the biggest perfect square that goes on into 160? All right, so I'll give you guys a moment, pause your video, and try that. All right, guys, here's your second strategy. So just a few steps here. I look at 160 and I see the number 16. I know 16 is a perfect square, so I broke down 160 to 16 times 10. And then I just rewrote it, guys, so that the square root of 16 times 10 is the same thing as the square root of 16 times the square root of 10. You can rewrite them as separate radicals. And then Once you take the square root of 16, you're left with 10 inside of your radical there. 4 times square root of 10. All right, guys, going a bit further, we're going to talk about adding and subtracting radicals now. So some important points to know. Make sure that the radicals, before you try to add or subtract them, that they're in simplest form. So basically apply what we just did with simplifying your individual radicals before you try to add or subtract them. Next point, in order to add or subtract radicals, the number inside the radicals must be the same. This is called the radicand. Here, I'll give you guys examples to know what that means. When the radicands are the same, then you can add and subtract only the numbers in the outside of the radicals, and these are called the coefficients. All right, the radicands are kind of treated like variables. So looking at some examples here, guys, if I had rad 2, or the square root of 2 plus the square root of 2 right here, you want to think of that, right? Your coefficient essentially is 1. We just don't need to write it. So you can see that here. When you add up 1 rad 2 plus 1 rad 2, that becomes 2 rad 2. So kind of think about it. I like the comparison over here. Think of that rad 2 as almost being treated like an x. So where you guys see x plus x, right? You know how to add your like terms up. That's like 1x plus 1x, which is just 2x, right? So you kind of keep that x the same, like we keep the rad 2 the same. Right? So I'll do one more with you guys, and then I'll have you try to on your own. So this one here, I look at number 7, I notice, okay, my radicands are the same. I have rad 6 for both of them. So I just want to add up my coefficients. That becomes 9 rad 6. All right, you guys pause 8 and 9, or pause for 8 and 9, try them. Notice for number 9, you might want to try simplifying your radical and then seeing if you can subtract. All right, guys, here are your answers for 8 and 9. 8's pretty straightforward. Just remember in front of that rad 11, you have a -1. So you got 3 rad 11, and then for number 9, make sure you took the time to simplify your 2 rad 45. I can break that down to 9 times 5, the 45. I know the square root of 9 is 3. So I pull that out of my radical. 2 times 3 is 6, and then keep 5 inside your radical sign. Right, so that becomes 3 minus 6 equals -3, and then just keep the rad 5 next to it. All right, some work with multiplying radicals. So same step as before, guys. You want to make sure that you multiply, or actually, sorry. Actually, you guys don't need to simplify your radical necessarily right away. You could simplify your radical, but you could just start off by multiplying the coefficients on the outside, multiply the radicals on the inside, and then simplify at the end if you want to do that. So you guys can see this example. We're multiplying 2 times 3 to get 6. And then the inside of our radical is 5 times 8 to get 40. And then can simplify it from there. Actually, you guys pause the video and try simplifying. All right, guys, that's your simplified version. I want to remind you guys too, you can always, if you ever want to do that factor tree, just know that's another option. So if I wanted to break down 40, 8 times 5, 4 times 2, 2 times 2, you'd still end up getting the same answer. So I can rewrite that as 6 on the outside of my radical, and then 2 times 2 times 2 times 5. Circle my pair, write 1 on the outside, and I still get 12 rad 10. All right, you guys try 10 and 11. Pause the video, and then we'll wrap it up. All right, guys, wrapping up this lesson, take a look at my color coding. Make sure that you multiply the outsides for number 10 to get 20. Make sure you multiply the insides of your radical to get 48. And then don't forget to simplify a radical. I can break down 48 to 16 times 3. I know 16 is a perfect square. Square root of 16, 4. And then multiply the outsides. 20 times 4 is 80. And then keep rad 3 on the inside. For number 11, multiply your outside. So negative 4 times 7 is negative 28. The insides, 3 times 15 is 45. And then I could simplify the square root of 45. Breaking down 9 times 5, square root of 9 is 3, and then I leave the 5 inside my radical, and then I multiply the outsides. Negative 28 times 3 is negative 84.